Hi guys, today I'm going to discuss about the question in chapter 2 atomic structure. So for question A, the Balmer series of hydrogen emissions spectrum is shown below. This is the Balmer series of hydrogen emission spectrum. The first question A1 is state the electron transition that produce line V. Line V is the first line in the Balmer series. As we know, Balmer series is when whenever the electrons fall from what energy level, they will finally fall to the energy level which is 2. So line V is the first line in the Balmer series. So that we can know that the energy levels, the initial energy level of the electron is 3. So the answer we can write like that, write like this. Transition of electrons is from n equal to 3 to n equal to 2. So let us proceed to the next question. Determine the wavelength of line W. We know that the line W is the second line of the Balmer series. So that in the second line of the Balmer series. So that the electrons of that produce line W is from the energy level which is 4 to the energy level which is 2. Thus, we can just substitute into the formula that in the chapter 2 lecturer note, and the RH value is the constant, and finally we find that alpha is equal to 4.862 times 10 power of negative 7 meter. Remember to write the meter is the unit. If we don't write the meter, we may deduct about 1 mark. Okay, so for question 3i, calculate the energy of proton that produce line X with wavelength of 434 nanometer. So in this question, the wavelength is given and we want to calculate the energy of photon. As we know, we have two formulas to calculate the energy of photon. One is this and one is similar like this. As the high energy level is have the wavelength is given, so we just substitute what the information is, and H and C is a constant, so we just can directly use the calculator to find the final answer, which is 4.583 times 10 power of negative 19 joule. Remember to write your unit. And because the energy of photons, the electrons is release the energy, not absorb the energy. So, and in the final answer, we need to give a negative sign to the final answer, which is negative 4.583 times 10 power of negative 19 joule. This is the final answer. Okay, let us proceed to the final question for A. Draw the electronic transitions of lines X, Y, and Z on the energy level diagram of the hydrogen atom. So this is the energy level diagram. The x-axis is the energy level and the y-axis is the energy. So how to draw the energy level diagram? We one skill is the energy level diagram. Each of the gap between the energy level, it will become smaller and smaller and finally reach a conversion limit. This is the conversion limit. The gap is becomes smaller. This is what we want to how to draw the energy level diagram. And we know that line X is the third line in the Balmer series. Line Y is the fourth line in the Balmer series, and line Z is the fifth line in the Balmer series. So that the line X is the electrons fall from n equal to 5 to n equal to 2. Line Y is fall from n equal to 6 to n equal to 2, and line Z is fall from n equal to 7 and n equal to 2. Remember to draw an arrow in here and finally write an energy and all the energy level. So that we finish the question A, let's proceed to question B. Okay, copper is the 9th element in the first row of transitions elements with proton numbers of 29. Write the electronic configuration of the copper atom. Give reason for the anomalous electronic configuration of copper. Okay, as we know, the copper atom, the proton number is equal to the number of electrons when when the element is atom. So we should highlight the atom. We should make sure that the question is not asking ion or atom, because ion they will have different proton different and different number of electrons uh, diff- uh, from the photon number. So if we follow the above principles, the electronic configuration of copper atom is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d9. But for copper atom, it's the special case because it's the M-minus case. So the um, the electrons in the 4s orbital, one of the electrons of the 4s orbital will directly fill to the 3d orbital, so that it will achieve a stable stability. Thus, the electron configuration of copper atom we should write 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, and 3d10 trend, because one electrons go to 3d orbital. For the reason, the anomalous electronic configurations of copper atom is due to extra stability of the completely filled 3d10 orbital. This can be copied from the lecture root. We should memorize it. Okay, for the next question, give a set of quantum number for an electrons in 3d orbital. As we know, a quantum number, it had n, l, m, s. So for n, it will refer to the tree, to the numbers beside the alphabet. So for n, quantum number is 3, and d is for the angular momentum quantum number, is for the l, and we has s orbital. S orbital is 0 angular momentum quantum number. P orbital is equal to 1 angular momentum quantum number, and finally D is 2 angular momentum quantum number. So n equal to 3, l equal to 2, and m can be positive 2, positive 1, 0, negative 1, or negative 2. So we just write either one, which is m equal to 0, and s we have positive 1 over 2 or negative 1 over 2, because we just need a set of quantum numbers, so we just choose either one. This is n equal to 3, l equal to 2, m equal to 0, s equal to positive 1 over 2. Okay, let's go to the final question. Draw the shape of orbitals for the 5th electrons in the orbital. So this is the shape of the shape of the orbital. As we know, we have the s orbital, p orbital, and d orbital, and f orbital. So how to identify the 5th electrons in the orbital? We know that the copper atom, the configuration of copper atom is 1s2, 2s2, 2p6. So the first electrons and the second electron is filled in the 1s electron 1s orbital, and the third and fourth electrons is filled in the 2s2 orbital, and then the fifth electron is filled in the 2p6. So we know that the p orbitals have 3 different shapes, which is px, py, and pz. So we just draw either one, which is 2px, and the dumbbell shape is lie on the x-axis. So this is the final answer. Okay, that's all for my video. Thank you.